Today, we are going to discuss about Simpson's first rule, but before anything else, let me introduce myself. I am Chief Mate John Racy Room, licensed Chief Officer, and 5 years maritime training instructor from the University of Cebu. So these are all our intended learning objectives. First, we need to define important terms used in calculating first rule. To be specific, enumerate the condition that should be met before using Simpson's first rule, state the formulas of Simpson's first rule, explain how to calculate Simpson's first rule using table method, and lastly, explain the importance of Simpson's first rule. So these are some of the terms that we are using for the calculation of Simpson's first rule. Ordinate, it is the vertical distance between 2 points on the water plane or area of irregular shaped flat surface of the vessel. So we have the example at the bottom. We have the water plane area of the submerged portion of the ship, where we can see here the line, the vertical line here is the ordinate, and halfway through it is the half ordinate. And for another example, area of irregular shaped flat surface, we have here the forecastle deck. So the same criteria, we have the beams from port to starboard. So the line is what we call as ordinate, and halfway through it is the same, we have half ordinate. So half ordinate is the midline. The midline will divide the ordinates into two equal parts. Hence, the ordinates on either side of the midline are referring to as half ordinates, or what we call as semi-ordinates. So please do not be confused on that. That is with the same meaning. Next, we have H. H is the common interval of the length and represents the width of the area, sections, or strips. Products. Products are calculated by multiplying the half ordinate by its corresponding Simpson's multiplier. Sum of products, of course, that is calculated by the summation of all products. Simpson's first rule is also called the 3 ordinate rule or the 1-for-1 rule. So you can use the Simpson's rule if you met the following requirements. When you have an even number of sections and an odd number of half ordinate. So we have here the example of an irregular shape, which we could apply Simpson's first rule to determine the value of the area. So let us try to see if these two requirements have been met. So let's count how many sections. So this one is a section, this one is another section, and we have consecutive sections. So let's try to count. We have 1, we have 2, 3, 4, 5, and 6. Therefore, we have met the even number of sections. How about the odd number of half ordinates? So we have, by the way, the tip, both the tip of the shape. So we have here the tip of the shape and the other one, the other side. So these are considered half ordinates. So we should include this one in to our counting. So we have 1, then 2 and 3 and 4 and 5 and 6, then 7 coordinates. Okay, so therefore 7 is an odd number, and we have met the whole requirement in order for us to use Simpson's first rule in this example. So what are the formulas to be used? If we are given half ordinates like this figure, this is only a half. So the formula to be used is area equals 1/3 times h times sum of the products times 2. Of course times 2 because it is only half, and if you are going to multiply the 1/3 times h times sum of the products into 2, then that would be the equivalent of another one like this one to make it a whole. So if given ordinates is already an ordinate, no? So we have area equals 1/3 times h times sum of the products only, so without 2, because it is already ordinates. It means that it is no longer half ordinates, it means it is a whole body. Okay, it's already a whole body like this one in our first. Okay, like this. Okay, so this is an ordinate, this is a half ordinate, so please remember that. So we have here the question before we proceed. Can we use Simpson's first rule to get the area of the above figure? Of course, the answer is definitely no. Why is it that we could not use Simpson's first rule? Since we have, or we do not met the requirements. First, we need to have even number of sections. So let us count how many sections. 1, 2, 3, 4, 5, 6, 7, 8, 9. So it means that it already does not met the requirement, no, of even number of sections. Okay, so either one of the requirement, if not met, rule number or first rule, or Simpson's first rule, I mean, should not be used. So we have here the example. So the length of the ship's waterplane area is 70 meters, and we have the equidistantly spaced half ordinates. We have the following: 0, 5.2, 6.4, 7.0, 6.0, 4.9, 0.3. The question is, find the waterplane area. So of course, no, we have 7 ordinates, so add number of ordinates, pass through the requirement, no, of using Simpson's first rule. Okay, so we have here okay, so we have here the table method of solving the problem. So we need first to enumerate, no, the half ordinates that are already given. Okay, so this is the illustration. So we have how many sections? 1, 2, 3, 4, 5, and 6. So that meets the requirements of Simpson's first rule. So again, list down the half ordinates and use the Simpson's multiplier. So we have 1 for 1, and since we have 7 ordinates, then we should use 1 for 2 for 2 for 1. So we have the 2 in between. but we should end up in 1, and before 1 is 4. Okay, so to give you more example for this one, if we have 9 ordinates, the multipliers that we should use is 1, 4, 2, 4, 2, 4, 2, 4, 1. So let us count how many. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that is 9 ordinates. Then if 11, so 1, 4, 2, 4, 2, 4, 2, 4, 2, 4, 1. Let us count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 ordinates. Okay, so simply just multiply it, and that will be the product. Okay, so these are the products, and the summation of the products is 93.5. okay, so by simply multiplying this one by 1/3, which is 0.33, times each, which is 11.77. So by the way, how did we derive from 11.77? Since we have how many half ordinates? We have 7. So we get 11.7 by dividing 70 to 7. So that would be 11.7. Okay, so we divide 70 to set the given 7 ordinates, and that would be equivalent to 11.7. So 1/3 times 11.7, so that would be 11.7 divided by 3, and times the summation of products times 2, because we only have half ordinate, and we are going to determine the water plane area. It means that the area that we are looking for is the entire area and not only the half. So therefore we should have the 2, or multiply the answer by 2. So therefore the water plane area is equivalent to 729.3 square meters. So to give conclusion to our topic, the importance of Simpson's first rule. So its strength is that although rectangles and trapezoids work better for linear functions, Simpson's first rule work quite well on curves. Simpson's rule is based on the fact that given any 3 points, you can find the equation of quadratic through those points. So we have these irregular shapes on board the ship. We have the forecastle deck, and on the left side we have the bulkhead. Okay, so if we wanted to determine the area, what is the reason for that? Probably we are going to determine the area because we need to figure out how much paint or how many paints, how many gallons or liters of paints do we need to fill up the area. Okay, so the same with the bulkhead. So that is the importance of Simpson's first rule. Shout out to all the members, and also shout out to all my BSM scholar students who created the PowerPoint presentation in this video. So that would be all. Please do not forget to hit the like and subscribe button. Also do not forget to hit the notification bell for you to be updated for our future videos to be uploaded. Again, this is Chipmate John Ray Zero at your service. Thank you and God bless.